In this topic, we're looking at sound, and one of the things that we're really going to focus on is the fact that sound, to be made, needs something to vibrate. And we're going to deal with what a vibration is. In your notes, it asks you to get an elastic band, and can you make a sound with elastic band? You stretch it across your fingers, and if you twang it, it makes a sound. What happens if it's tighter? We get a different pitch of notes. The tighter the band, the higher the note is. Can we do something similar with a ruler? I'm sure you've all got a ruler before and you've twanged it off the end of your desk. We can see that by changing the length of the ruler, we can change the note that's produced. And what we're doing is we're changing how quickly the ruler vibrates. When there's a very long amount of ruler, it vibrates quite slowly. Whenever it's a much shorter length of ruler, it's a much faster vibration. And so we're going to look at how we can measure the length of time it takes for a single vibration. So what is vibration? A vibration is something that is moving backwards and forwards repeatedly about a fixed position. So there I've got a conker, and that conker normally hangs in the middle, but if we pull it back and let it go, it's going to move backwards and forwards, and that is known as a vibration or an oscillation. Something that vibrates backwards and forwards like this is known as a pendulum. So it's maybe like being on a swing. And what we're going to do is we're going to measure the length of time it takes for one complete vibration. But first we need to know what is one vibration. If I swing this, I'd like you to count to see how many vibrations you think there are. So if we start as soon as I let go. So how many was that? Was it one vibration, or 5 vibrations, or 10 vibrations, or some other number? That was 5 vibrations. A vibration is one complete movement from a starting position to the other side and back again. So start 1, 2, 3, 4, 5. So we need to measure a complete vibration from one position to the other and back again. A vibration could be whenever you're on a swing, moving backwards and forwards, that's a vibration. Or if you're on a trampoline, bouncing up and down, that's a vibration. There's a central position and you move up and down or left and right away from that central position. One complete vibration is from one side of the motion to the other and back again. On page 5 of your notes, there's an experiment in which we are going to try to measure the length of time it takes for one complete vibration of a pendulum. Now, we don't have all the equipment that you need at home, but we can use other things that we find around the house to make our own pendulum, and we can do this experiment ourselves. Here are a few different things that we could use for our pendulum. I say I've got a conker and a bit of string. I've tied some keys to some string and they can swing backwards and forwards. Or I've got a nut and a bit of string. I'd like you to find a bit of string or a bit of wool or cord or something like that, and something with a bit of weight that you could tie to the end of it. And we're going to use that for our pendulum. For my pendulum, I'm going to use a nut on a bit of string, and I'm going to hang it off the end of my desk so it can swing backwards and forwards. And to hold it in place, I'm going to use a can of beans. And I think you can do something similar. You can find some heavy weight on top that's going to allow us to have a pendulum that moves. Whenever you do this, make sure that whatever's holding this is heavy enough to hold this in place. Here, this is not really heavy enough. If I give it a bit of a pull, that would not be good. You're firstly going to need to measure the length of your pendulum. I'm assuming you do not have a meter rule at home, but you do have a ruler, I'm sure. Or if you don't have a ruler, a tape measure might be useful. And we're going to repeat this experiment for 3 different lengths of pendulum. To measure the length of a pendulum, we measure from the top corner of the desk, that's the point where it's swinging from, down to about the middle of the heavy object. So in this case, that's at about 26.5 centimeters. Be precise with your measurement. Your ruler can measure to a millimeter. You should give your answers to a millimeter. If you just let your pendulum swing once, so start, stop, and try to time that, it would not be the most accurate thing in the world. There's a certain reaction time you have whenever you start or stop a stopwatch, and that's fairly significant compared to the very short length of time of your measurement. So to make it more accurate, what we're going to do is we're going to measure the length of time it takes for 10 vibrations. And once we do that, we can divide that number by 10, and that will give us the time for 1 oscillation. To do that, you can use the stopwatch on your phone. I'm going to use a tablet here. And a tip that I give, this is an experiment that our A-level pupils do, is not to measure from the very side, but to measure from the middle. So if I let go there, and as it swings, start. 1, 2, and count every time it goes through the middle of the motion. The middle never changes, and that's a better way of doing it. So I'm going to remeasure this because this has slipped a little bit, and we're going to take our times. As well as measuring the time for 10 vibrations, we're going to do that 3 times so we can take an average. And this is going to allow us to take a really accurate measurement. So we don't want to let the pendulum slip. The length of my pendulum is now 29 centimeters. I'm going to record that in a table. I'm going to start it vibrating. I'm going to start the stopwatch when it passes through the middle of some motion, and we'll count it through. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In this case, I've got 10.94 seconds. And we'll repeat that 2 more times and take an average. Then you're going to repeat the whole thing with a different length of pendulum. You're going to extend your pendulum to a different length, measure its length again, and repeat the experiment. So by the end, you will have 3 different lengths of pendulum. For each length, you'll have measured 3 times, each for 10 oscillations. You can average those 3 times, and then divide that average by 10 to get your time for 1 oscillation. And you're going to record all this in your notes.